Hello! In our second video about sequences, we are going to learn about arithmetic progressions. First of all, we are going to learn what are arithmetic progressions. An arithmetic progression is a type of sequence in which each term can be calculated by adding to the previous term a certain quantity, always the same. So here I have the recurring law of an arithmetic progression. For example, 3, 7, 11, 15, 19 is an arithmetic progression because when I go from the first to the second term, I'm adding 4. When I go from the second to the third term, I'm adding 4. When I go from the third to the fourth term, I'm adding 4. And when I go from the fourth to the next to the fifth term, I'm adding 4. So it could be possible for me to complete some new terms because I can continue with 23, 27, 31, just adding 4 each time to the previous term. Another example, 8, 6, 4, 2, 0, minus 2 is also an arithmetic sequence because when I go from the first to the second, I'm adding minus 2. When I go to the second, from the second, to the third, I'm adding minus 2, and so on. This quantity I'm adding from each term to obtain the next one. It's called difference. And it's possible with the definition of difference to calculate the general term of an arithmetic sequence, as each term can be calculated by adding to the first one, which is known, how many times the difference. When I want to calculate the second, I have to add once to the first term the difference. When I want to calculate the third one, I have to add twice. When I want to calculate the fourth, I want to add 3 times, and so on. So when I want to calculate the nth, I'm adding n minus 1 times the difference. For example, for the first sequence, an will be the first term, 3 plus n minus 1 multiplied by 4. And this can be written as 3 minus 1 multiplied by 4 minus 4 equals minus 1 plus 4n. And in the second sequence, I wrote bn could be calculated by taking the first term and adding to it n minus 1 multiplied by the difference. So 8 plus minus 1 multiplied by minus 2, which is 2, equals 10 minus 2n. For arithmetic sequences, I only have to know something more. If I have the n first terms of an arithmetic sequence or progression, and I want to add all of them, the addition of all these n terms can be calculated by the first of them plus the last of them multiplied by the amount of terms I want to add and divided by 2. So for example, if I have the sequence 3, 7, 11, 15, etc., and I want to calculate the addition of the first 20 terms, what I need is to calculate the addition of the 20 terms as the first term plus the term number 20 multiplied by 20 and divided by 2. I know A1 equals 3, and to calculate A20 I have to use the general term, which is A1 plus 19 multiplied by the difference. So 3 plus 19 multiplied by 4, 19 multiplied by 4 equals 36 plus 3. I told 36, I wanted to say 76 plus 3, 79. So this addition equals 3 plus 79 multiplied by 20 and divide by 2, which is 820. And this is the way I can add as many terms as I want. And that's all I have to know about arithmetic sequences.